Hello again, my name is Brianna Burnett, and this time we are talking about speed, velocity, and acceleration as we move into the physics of motion. So let's first begin with a definition of motion. Motion is an object's change in position relative to a reference point. So whenever you are determining whether or not something is moving, you're looking to see how it changes position from one point to another. So for instance, if I am, I'm moving a hand, I have a reference point. Let's say my left hand is the reference point, okay? So as it moves, as you're looking at my left hand, you're seeing it staying in place, okay? It hasn't moved in relation to my hair, in relation to the wall, but my right hand is moving in relation to my left hand. So if you're looking at a car, if you're looking at a plane, anything that's moving, you are going to evaluate it against the background and see how close is it getting to point B, how far is it getting from point A, and that lets you know if motion has occurred. So whenever we look at motion, we need to learn how to calculate speed. Speed is the rate at which something can move, okay? So it always has a positive value. If there is speed involved, it is always positive. Speed is represented with an S, and it equals the distance traveled, or D, divided by the amount of time it took, or T. So in a simple math equation, it is speed is equal to distance divided by time. And one thing that I really like to do that makes math equations a little bit easier if you're not very good at changing up, swapping things out in an equation, I like to use this magic triangle here, which shows speed is equal to distance divided by time, okay? So let's say you needed to find out distance. Distance is equal to time times speed. If you needed to figure out time, time is equal to distance divided by speed. So the units that we use for speed totally depends and varies based on the different units you're looking at to begin with. So it will always be represented as a distance unit over a time unit. So for example, we generally talk about our cars traveling in miles per hour, so a distance unit divided by a time unit. Jets, we talk about kilometers per hour. Snails probably move at centimeters per second, okay, or centimeters per minute. Falling objects we measure in meters per second. Okay, so let's take some time to figure out how to calculate speed, or average speed. So I have the equation here. Speed is equal to distance divided by time. So let's start with two very simple examples. If I travel 100 kilometers in 1 hour, then I have a speed of. So the first thing we want to figure out is what are we looking to solve for? So we have two numbers, and it says I have a speed of blank. So we're looking for speed. So I like to take note of everything I have, okay? So speed, we don't know. I have this number, 100 kilometers. I know kilometers is a unit of distance, so that's my distance. And I have 1 hour, and I know that hour is a unit of time, so that's my time. So if I write out my equation, speed is equal to distance divided by time. We've got 100 kilometers divided by 1 hour. When we multiply that out, it's very simply 100 kilometers per hour. Now that one's simple because we're working with divided by 1. But that's how you generally set it up. How about this one? If I travel 1 meter in 1 second, then I have a speed of. Again, we're looking for speed. What is my speed? I travel 1 meter, so that's my distance, in 1 second, which is my time. So if I put that into my equation, speed is equal to distance divided by time, we have 1 meter divided by 1 second, which gives us 1 meters per second. Pretty simple and straightforward. So let's try with a little bit more difficult numbers. Mr. Plunkett is preparing for a triathlon. He bikes 360 kilometers to build his stamina in 4 hours. What is his average speed? So what are we looking for? At the very end it asks us, what is his average speed? So the question mark goes with our S. What numbers do we have? He bikes 360 kilometers. Kilometers is a unit of distance. So 360 kilometers to build his stamina in 4 hours. Hours is a unit of time, so our time is 4 hours. If you'll remember, our equation is speed is equal to distance divided by time. So if I put that all together, I have 360 kilometers divided by 4 hours. We divide that out, we get 90 kilometers per hour. Make sense? All right. So for the next one, it's a little bit different. Let's read it together. Ms. Nightingale walks her dog at a speed of 10 kilometers per hour in 2 hours. How far did she walk her dog? We're looking for something different here. How far? That's a unit of distance. So as a hint, I want to remind you of the magic triangle I showed you earlier. We've got speed is equal to distance divided by time. This horizontal line represents division. So this divided by this divided by this. This vertical line represents multiplication. So this times this, okay? So if you need to solve for distance and you have these two numbers, you're going to multiply. So take a second and work through that. All right, so let's look at that together. One of our numbers is 10 kilometers per hour. It says a speed of, okay? So we know our speed is equal to 10 kilometers per hour. Ms. Nightingale walks her dog at a speed of 10 kilometers per hour in 2 hours. That's a unit of time, so our time is equal to 2 hours. Because of this magic triangle, I know that my speed is 10 kilometers per hour, and I know that my time is 2 hours. So I can use this triangle to show me that distance is equal to speed times time. So if I multiply that all out, it's 10 kilometers per hour times 2 hours. That gets me 20 kilometers. So where did the hour go? Because there was an hour on the bottom of this little unit fraction, and technically there's a 1 under this, we can cancel out the hours, which leaves us with just 20 kilometers. So let's look at the difference between speed and velocity. Velocity is the speed and direction of an object. So we are looking at how quickly it's moving and what direction it is moving in. It may have a positive or a negative value depending on the direction of the change in position. So for example, an airplane moving north at 500 miles per hour, that is velocity. A missile moving towards a target at 200 meters per second, that's velocity. Towards a target is the direction. So let's do a quick review. What is the difference between speed and velocity? So speed is the rate at which something moves. Velocity is the rate at which something moves in a particular direction. So whenever we're graphing speed, we're looking at distance versus time graphs. So on this graph, we have a plane traveling from Phoenix to Denver. On the y-axis, we have distance measured in kilometers, so 0, 200, 400, 600, all the way up to 1,600 kilometers. And across the x-axis, we have time measured in hours, and we've got 1 through 7, okay? So as we look at this, in hour 1, we traveled 200 kilometers. So 200 kilometers per hour. If we look at how fast we were going at 600 kilometers, 600 divided by 3, 200 kilometers per hour. 1,200 kilometers divided by 6 hours, 200 kilometers per hour. So this plane traveled at a constant speed over time. So below on this picture is a distance versus time graph for 3 runners. Take a second and look at this and tell me who you think the fastest runner is. So as we look at this, we're looking at who traveled the fastest in the short amount, who traveled the farthest in the shortest amount of time. So it looks like they all achieved the same distance. They all went 6 miles. But who did it faster? We have to look at the time. So it looks like Leroy in the blue with the blue triangles, he accomplished the 6 miles in about 2.5 hours, whereas Jane accomplished it in 3.25 hours, and Bob accomplished it in 6 hours. So, according to this graph, Leroy is definitely the fastest runner. So acceleration is a little bit different. Acceleration is the rate at which velocity changes. So now we're talking about velocity changing. This can be an increase in speed. So typically if you're driving in a car and you talk about acceleration, you talk about going faster. So you're increasing in speed. But that's not the only way we can accelerate. If you slow down, that is also a type of acceleration because you are changing velocity. If you change directions, that is also acceleration because you have changed the direction. You've changed your velocity. Even if you continue at the same rate of speed, when you change directions, you have accelerated. So let's look at some examples. A car speeding up at a green light. That is a type of acceleration, okay? You're increasing your speed. Decreasing speed is a car slowing down at a stoplight. Changing direction, an example is the car takes a turn, even if it's at constant speed. So let's talk about positive acceleration. An object speeds up. So acceleration is in the same direction as the motion. Acceleration, same direction as the motion. For example, you are riding your bicycle in a straight line and that should say sped up or speed up, and you speed up from 4 meters per second to 6 meters per second in 5 seconds. So you have a positive acceleration. You are riding your bike in the same direction as you are accelerating. Negative acceleration is when you are kind of going opposite, okay? An object slows down, which means the acceleration is in the direction opposite the motion. So deceleration is a decrease in speed. For example, you slow down on your bicycle from a speed of 4 meters per second to 2 meters per second in 5 seconds. So the acceleration, right? This is the speed you're going. The acceleration is the opposite direction of your motion as you are applying your brakes. So graphing acceleration is a little bit different. You have distance over time here, okay? And if you have a distance over time graph, your acceleration is going to be represented with a curve. So if you had constant acceleration, you would have a nice straight line. But whenever we're graphing acceleration on a distance versus time graph, you're going to wind up with this very nice little curve. So I want you to tell me which line represents an object that is accelerating, which line represents positive acceleration, and which line represents negative acceleration. So hit pause for a second and look at that and let me know what you think. All right, so let's answer these questions. 1. Which lines represent an object that is accelerating? So we are looking at a distance versus time graph, and as we just discussed, you can tell acceleration by a curved line. So on this graph, you'll notice we have two curved lines. We have our black line and we have our red line. These are both representing acceleration. Which line represents positive acceleration? Because the distance traveled is increasing as the time increases, the black line represents positive acceleration. The red line, because the distance traveled is going down as time increases, that represents negative acceleration. So what do the blue and green lines represent? Constant speed. So objects going in circles. Why are objects moving in a circular motion constantly accelerating? Well, that's because they're constantly changing direction. So that wraps up our lesson on speed, velocity, and acceleration. As a refresher, speed is the rate at which something is moving. Okay, so you are looking at distance divided by time. Velocity is the rate at which something moves in a particular direction, north, south, east, west, towards Main Street, towards the school. And acceleration is when you change velocity. You increase it, decrease it, or you are changing direction. I will see you later.